Experiment 4, Determination of crystal field splitting energy, delta naught for nickel, 2, complex. Objectives. First, to determine the crystal field splitting energy for some of the nickel, 2, complexes. Second, to develop the spectrochemical series by investigating the colors of the complex ions formed. Introduction. The crystal field theory can be used to explain the color properties of the transition metals complexes. The color of the complex arises from the crystal field splitting of the 5 degenerate d orbitals into 2 energy levels by certain ligands. An electron can move from an orbital to a higher energy orbital by absorbing light that has exactly the same energy as the energy difference between orbitals. To relate this energy to the wavelength absorbed, the radiation energy, E, can be calculated from Planck equation as follow. E equals delta 0 equals hc slash lambda joule, where h equals Planck constant, c equals velocity of light, and lambda max equals wavelength of the light absorbed at the maximum. Based on crystal field theory, when a transition metal is surrounded by anions, the d orbitals are no longer all the same energy due to the anions increase the energy of the orbitals closest to it. As a result, other orbitals must then decrease in energy. So, the d orbitals of a metal ion will split to 2 sets with different energy levels when the metal complexes with the ligands. The first set is called dg orbital, which consists of 2 orbitals, dz2 and dx2y2 at higher energy level. The second set is called T2G orbital, which consists of 3 orbitals, dxz, xz, and diz, at lower energy level. The crystal field splitting energy, delta naught stands for octahedral, is the energy between dxz, xz, diz and dz2, dx2y2. The magnitude of the splitting of the T2G and dg orbitals changes from one octahedral complex to another. It depends on the identity of the metal ion, the charge on this ion, and the nature of the ligands coordinated to the metal ion.